Hello and welcome to today's lessons. We're going to be talking about pH and pOH is what that should say. Calculations, typo error there. So I'm going to try to get through just some of these notes real quick and we can talk about more of them in class. Again, hopefully you are working on memorizing your strong acids on there. And what we're going to be talking about here today is monoprotic strong acids, which just means that they have one hydrogen. We'll talk about some of the diprotic and triprotic acids later on, but that's what we're going to talk about. We're also going to just talk about strong acids for the most part today on there. And then again, hopefully you are working on memorizing your strong bases, which again are the group 1 and group 2, and there's just a couple of those on there. So one of the things that we will talk about, and again we can go more into detail in class about it, but when we're doing the concentration of your acid, we use the concentration to find the pH. So your pH is based on your concentration, and it is defined as the negative log of your hydrogen or hydronium concentration, and then also the pH or the negative log of your hydroxide ion. And remember, pH is base 10. Also, the other thing about the pH values is that it is based on temperature, standard temperature and pressure, so we are going to have it at 25 degrees Celsius. We'll look at on one lesson what happens if the temperature changes, but for right now everything is going to be at 25 degrees Celsius. If you look at your pH scale, anything less than 7 is kind of how we define acids, and anything greater than 7 is bases, although again we will talk a little bit more about those. And then again, 7 is considered neutral. So what we're really going to be using today is this formula here. And if you'll look at your formula sheet, I believe it is on there. And then the next thing to talk about is that using our log, remember that the log of something is the same as going to exponential as 10 to the, so 10 to the answer equals what's here, and a lot of you guys called that bay, so 10 to there equals that. So that is going to be, again, sometimes if we are given the pH and we're looking for the concentration, we're going to have to do that. So these two. Now this one is not given on your formula sheet, so you do have to know how logs work on that. Another one is here that if you take the concentration of your hydrogen ion, concentration of your OH ion, it should always equal 1.00 times 10 to the negative 14. Okay. So if you take the anti-log of that, then we're going to get that the pH and the pOH together will always equal 14. So if you know the pH, you can easily calculate the pOH by subtracting from 14. Again, your pOH is the negative log of your hydroxide ion. And again, if you know your if you know your pH, then it's 10 to the negative pH. There is a, they call it the pH square. I personally don't use that, but I did leave it in there if that helps some of you. According to, again, where you're going, which direction, if you're going from pH to pOH, again, here's what it tells you to do. If you're going from pOH to the concentration, here's what you do, and so forth. So you just follow the arrows around. Of course, you can't jump across, so if you had pH and you want, or sorry, if you had the concentration of the hydronium ion and you wanted a pOH, you would have to go around the square. Okay, so like I said, you are welcome to use that on your homework, although that will not be given to you on the test, so don't become too comfortable with it. The next thing, again, and we can talk a little bit more about it, but misconceptions is that your pHs are always from 0 to 14, and that is not the case. There are times where it actually becomes less than 0 or greater than 14 on that, but usually not much, but there is a little bit of a leeway there, we should say. And they give you an example here. If you've got 12 molar hydrochloric acid, its pH is about negative 1.079. So you can see that's slightly less, but not tons. Okay, and then we'll talk about the auto-ionization. That is for water on there. And remember from our last lesson when we were doing conjugate acid, conjugate base, on there we did talk about that water was amphoteric on there. So this kind of goes back to that, and the fact that if a substance ionizes when one molecule of a substance reacts with another of the same, it's referred to as auto. So what we mean by that is you've got water that is technically going to be reacting with itself. Okay, auto. So it doesn't need anything else in order to ionize. Okay, it can ionize all on its own. Okay, let's see what else we want to talk to you real quick about. Remember, we just came out of all of our Ks. We had K, EQ, K, SP, Q, EQ, Q, SP, so forth. And now we've got another K value, another equilibrium value. And this is KW, and it is the constant for water. That's what the W stands for. And that value is the 1 times 10 to the negative 14th power. Okay, so your KW equilibrium number is the 1 times 10 to the negative 14. And you can double check. I'm not sure, but I think that is on your sheet. So you can double check that. I know this is, but I can't remember if the number is. So again, double check that. Okay, and as I said, we'll kind of go through some more of this in class if you have any questions on it. But probably most of it you've had somewhat in Honors Chem. Okay, so I pretty much already told you this. Equilibrium constant. Here it is again. You can read through, again, the discussion of that, but it will be calculated, again, just as we've done before, products over reactants, but again, same as what we've done before, your solids and your liquids do not count, therefore there's nothing in the denominator here. Okay, and I put that note in there for you. Remember, your solids and your liquids are not in the concentration formula. Okay. And then I mentioned earlier that your pH was based on the 25 degrees Celsius. So let me just show you real quick here. This again, this KW does depend upon temperature, and the auto-ionization of water is an endothermic reaction on that. And so there is a table of values here. And you can see that the temperature is changing, which as the temperature changes again, it changes your KW value. Okay, so look through there and it changes it. Again, our normal that we use would be at 25, which would be right in here. Okay. And again, at 25, we're at 1 times 10 to the 14th. So you kind of see it's very close here. It has a pH of 7. And then what would happen over here, again, is you would have 7 and 7 for your concentrations. Now, the thing to take away from this is, one, again, pH is temperature dependent. If the temperature is not 25, it will affect your KW. Also affects your pH. But the thing that is true, no matter what, and this is one of the big takeaways I want you to have from this, is that no matter what temperature it is, your concentration, my highlighter's about gone, your concentration of your hydronium ion is always going to equal the concentration of your hydroxide ion ion, and it doesn't matter at what temperature. Those two concentrations, okay, will always be equal to each other at your kW, at your temperature. Okay, so this would be your 1 times 10 to the 14, your pH of 7, since it is your, in this case 7 would be your pure water, those two are going to be equal. Okay, so even though temperature affects the pH, okay, at neutral, that's what this is. This is all, I should have put that in here somewhere. Oh, well, it's up here in the reading. Okay, so we're talking about neutral. Okay, so make that note here. So normal, we're talking about neutral as in pure water. In this case, when we're talking about a neutral compound, not an acid, not a base, but neutral, those two are always going to equal each other. Okay, let me add one more thing and then I'll be done here. And it is, how do we write sig digs for acids? And acids have their own little rule for sig digs. Okay, and your significant digits for your pH is only the numbers after the decimal point. What I mean by that is if your problem has 2 significant digits, okay, then in terms of pH, you would have number like these 2. So these would be the 2 that you count. You don't count the 3. So if your number is supposed to have 2 significant digits, it's only these 2 that we're counting, not the 3. Okay, so if you had 3 sig digs in your problem, then the pH or pOH, either one, would be 3 digits there. I could go back and do 1 sig dig. Okay, your pH would be 3 point something. So why they come up with that rule, there's I'm sure in their mind a logical reasoning for it, but for us we just need to memorize that piece of it so that you get your significant digits correct. Okay, we'll go do some problems.